Okay, so the next question that we have here is that we want to find basically the mean and the variance of the first 10 multiples of 3. The first 10 multiples of 3 are basically 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and all the way up to 3 times 10. Meaning that you have basically 3, 6, 9, 12, 15, 18, 3 times 6 is equal to 18, 3 times 7 is equal to 21, 3 times 8 is equal to 24, 3 times 9 is equal to 27, and 3 times 10 is equal to 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 numbers here. So now if you want to find the mean of these numbers, it's simple, meaning that you can write your numbers, for example, in a table, for example. You can write your numbers in a table like this. Call them, for example, your x of i's. Call them your x of i's. And then they are 6, 9, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And where the f of I is related to these are all ones. I don't think you really need to write them, but let's see if that's actually required or not. And then you know that basically your x bar is equal to sigma f of I x of I divided by sigma f of I as I goes from 1 to n, as I goes from 1 to n. So I can write this as, since all of your f of i's are equal to 1, you can write it as sigma x of I as I goes from 1 to, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 1 to 10. And over here again you can write sigma f of I as I goes from 1 to n. And as you can see, your sigma f of I is actually equal to 10, because 1 plus 1 plus 1 10 times, so that would be 10. So your sigma f of I as I goes from 1 to 10 is equal to 10. So that is equal to 10. And your sigma, basically sigma x of I as I goes from 1 to 10 is basically the sum of these numbers, which is you can calculate them that way, or you can use, for example, you can basically use the idea of arithmetic progression in order to find the sum of these numbers, meaning that, as you can see, the numbers are 3 plus 3 is 6, 6 plus 3 9, 9 plus 3 12, plus 3, and so on and so forth. So that means that we said that in an arithmetic progression, well, basically your first term over here is called A. The common difference of the numbers is called D, which is basically, for example, 6 minus 3 is equal to 3, 9 minus 6 is equal to 3, 12 minus 9 is equal to 3. That's called the common difference. That is called the common difference. And then you have some other measure as well, which is called n, which is, well, the number of terms that you have. And That's it basically. So there is a formula S of n is equal to n divided by 2 times A plus n minus 1 times d. That is the formula that you can use. So since n is equal to 10 here, I can write S of 10 is equal to 10 divided by 2, which is equal to 5, times 2 times A, which is 2 times 3 is equal to 6, plus n minus 1, which is 10 minus 1, which is equal to 9, times d, which is 3 in this case. So you have 5 times, for example, 27 plus 6 is equal to 33, is equal to 33, and so you have 5 times 30 is equal to 150, 165. So the sum of these numbers is 165. So then I can write 165 divided by 10 is 16.5. And if you add these numbers together, the usual way using, for example, calculator, you would get the same answer. Meaning that if I write 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21 plus 24, for example, plus 27 plus 30 is equal to 165. So that's basically the mean of your numbers is basically 16.5. So x bar is equal to 16.5. Now the next part that we have here is so sigma x of I is actually, okay, that we don't need it really, I suppose. Now, the next thing that we need here is find the variance of the data. The variance denoted by sigma squared, sigma squared is equal to 1 over n times sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. That is your variance. That is your variance. So let's see if we can find the variance of this data. Okay, so now in order to calculate variance, I need x of I minus x bar and then square it. So I need to calculate it here, x of I minus x bar whole squared. And for example, 3 minus 16.5 is equal to negative 13.5. So negative 13.5, and you want to square this number, meaning that you have 135 times 135, which is 5 times 5 is equal to 25, 15, 17, 1, 5, and 6. 3 times 5 is equal to 15, 1, 3 times 9 is equal to 10, 1, 3, and 4. And you have 135 here. So you have 5, 12, 1. That's a 12, 1, 8, and 1. And you have 1 decimal place here, 1 decimal place here, so you get 2 decimal places. That's 182.25. 182.25. Now the next number that we have is basically 6 minus 16.5. So that would be negative 10.5. Negative 10.5. Now 10.5 times 10.5, of course the negative sign is going to be a positive, but 10.5 times 10.5, you get 2 decimal places. So that's a 25 and 5 and 0 and there you would have all zeros, so another 0, and then 105. So you get 5, 2, and 5 plus 1 is equal to 10, 1, and a 1. And 2 decimal places that's 110.25. 110.25. Then you have, for example, 9 minus 16.5, which is the same thing as 16.5 minus 9 is equal to basically 5, and 17 minus 9 is equal to 9 plus 8 is equal to 17, so that's negative 8.5. You get negative 8.5. And now 85 times 85, 85 times 85, and you have 2 decimal places, you get 5 times 5 is equal to 25, 2, 40, 42, 0, 44, 64, 70, and you have 5, 2, 4, 7, 7, 4, 2, 5 with 2 decimal places. You have 74.25. The next number that we have is 12 minus 16.5. That's negative 4.5. Now 45 times 45 is equal to 5 times 5 is equal to 25, 2, 20, 22, 22, and 16, 18. So you got 5, 0, and 4 with 2 decimal places. So you get 4.05. And of course you could, for the sake of simplicity, you can do your calculations this way, because when you get the 0.5 part, first of all, subtracting is not easy, and then multiplication is not easy either. Of course, that doesn't make any difference for the multiplication part, but otherwise, for example, you have 15 minus 16.5. 15 minus 16.5. So, and I want to square it, right? So what that means is that I know that I can write this as basically 15 minus 16, 15 minus 16 whole squared plus 15 minus 0.5 whole squared, right? Because 15 minus 16.5 whole squared, I can write it as 15 minus 16 plus 0.5 minus 0.5 whole squared. So then I can write this as 15 minus, I can write this as I think that's a weird thing. I think you can write this as 15 minus 16. Okay, so you can write this as 15 minus 16 plus 15 minus 0.5, and then square, basically square the whole thing, of course. Not this way, but then you have to square the whole thing. So that means that I can, well, that it's not really worth it. Let's not do that. So now I have 15 times 15 minus 16.5, which is negative 1.5, and you can take that as 15 times 15, and 15 squared is equal to 225, 2 decimal places, that's 2.25. 2.25. 18 minus 16.5 is equal to 1.5. Again, you will get 2.25. 21 minus 16.5 is equal to 4.5. 4.5. 21 minus 16.5 is equal to 1, 11, 10, and 10. So that's a 5, that's a 4, that's 4.5, right? So 4.5 times 4.5 is 45 times 45. You need to know these things. They are very useful in calculation. So 5 times 1 is equal to 25, 2. 5 times 1 is equal to 20, 22, 0. 4 times 1 is equal to 22, 16, 18. Then 5, 2, 0. And 2, 20, 25. 2 decimal places is 20, 25. Is 20.25. Now, what you can do in order to find, to learn these, of course, while you're doing calculation, you will learn them, I mean, the ones that happen, that repeat themselves so often, you will learn them automatically. But otherwise, you can make a table. I actually never happened to do that, but, because whenever you're calculating, it's actually working with numbers is fun. So you don't wanna, I mean, there is no need to make it faster, really. But if you do need to make it faster, then you can, for example, go for example, 1 squared and 2 squared and 3 squared, 4 squared, 5 squared, 6 squared, and go all the way to, for example, I don't know, 25, 30, 35 or so. 35, for example, squared. If you learn, for example, these numbers, then you can use them in calculation. Or you can basically, while you're calculating numbers, you can make tables for yourself. Whenever something happens, for example, 15 squared happens and it's for example 225, you can basically collect these and put them in a table for yourself by your side. Whenever you're doing mathematics, then you can take a look at your table and see basically what is, for example, 15 squared or 16 squared, and so on and so forth. It's, in most cases, it's easier than calculating it with the calculator, because as you can see, for example, if I were to do this, for example, 15 squared here, I would simply write it as 15 squared and calculate it, rather than going to this calculator, and it takes some time to come up, and then I have to enter here 15 times 15, enter, and then it gives me 225. It's harder for me to do it this way than doing it just by hand. It's easier for me and much more pleasant. So anyway, you can basically, that would be just a part of your workflow. You know better than anyone else what to do with that. 24 minus 16.5. 24 minus 16.5 is 4, and you have 4 plus is equal to 7, so that's 7.5, and 75 times 75 is equal to what? 2 decimal places, 25, 2, 35, 37, and then you have 7 times 5 is equal to 35, 3, 49 plus 3 is equal to 52. And then you have 5, 12, 1, 6, 5, 5, 6 to 5, that's 56.25. Then you have 27 minus 16.5. 27 minus 16.5. You have 7 over there. 3, 10, 10.5. So 10.5, that's 105 times 105 with 2 decimal places. You get 5 times 5 is equal to 25. 5, 0, 0, 105. And then you have 5, a 2, a 10, and a 1, and 2 decimal places, 110.25. 110.25. And then you have 30 minus 16.5, you have 10, 13, 13.5, and 135 times 135 is equal to 2 decimal places. 5 times 1 is equal to 25, 2, 15, 17, 1, 5, and 6, 0, 15, 1, 9, 10, 1, 3, 4, and 2 zeros, 135. 135, you have 5, 12, 1. So that's a 12, 1 again, that's a 8 and 1. 2 decimal places, 182.25. 182.25. And then what you need to do is, now I have basically sigma, I have x of I minus x bar whole squared. F of I is not important here, because if I calculate basically f of I times x of I minus x bar whole squared for these observations, I'm going to get the same numbers, because all of my f of i's are the same. Are of course the same, and 1 of course. So I don't need to calculate this. So what I need to do now is basically take the sigma of all of this, meaning that if I calculate the sigma of x of I minus x bar whole squared, that's going to be all of these numbers added together, and then you can leave out these all of these decimal points. We will add them back in once we are done with the whole parts. So you have 182, you have 110, you have to separate them a little bit. 182, you have 110, you have 74 plus 4 is equal to 78, 80, 82, 102, so up to here 102. And then you have 56 plus 110 is 100, 166, and then 182. So you can add these numbers together. That's a 4, 6, 10, 12, 1. That's a 10. 10 plus 14 is equal to 24, 2, 2, 3, 4, 5, 6, and 7. 742 is the whole part. Now you have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 0.25, and you have 1 time 0.05. 0.05. So 9 times 25 is equal to, well, that's the same thing as 10 times 25, which is 250, and then you subtract just 1 times 25, which is 25. So you have 225. And you have basically 2 decimal places, that's 2.25. 2.25. And this is 0.05. 0.05. Add them together, you'll get 0, 1. You have a 3 here, and 2.3. So that's 744 actually. 2 plus 2 is equal to 4.3. That's this number, 744.3. If you have fun while working with the numbers, of course you can do it. Otherwise, you can use a calculator as well if you don't like it. Now I have my sigma f of I times x of I minus x bar and sigma f of y is equal to 10. So I can write this as basically 744.3 divided by 10, which is the same thing as 74.43. That is the variance of, or sigma squared of my data. So that's number 3. Let me see what the answer is. Okay, now 15.2. So number 3 is 74.25, and that's 16.5. I don't know how, but the number that they've gotten is 74.25. We could have made some sort of mistake here. That's possible, but the answer is very close. I don't know if it's happened through rounding numbers or anything like that, but that's basically how you, for example, solve this problem. Okay, so now question number 4 is again the same story, just we have some data here really. That's the only difference. Okay, so the next example that we have is we have some data, some observations, a discrete, what you would call a discrete frequency distribution, discrete frequency distribution, and then basically what you want to do is find the mean and the variance of these observations. Okay, so I did actually solve this problem, and it took me about, I don't know, 15 minutes or so, but it seems I did something wrong. And now let's do it again. 409. Okay, so the data that you have is basically this data over here, which is let's say that these are your x of i's and these are your f of i's. So you have these x of i's here and these f of i's here, and 6, 8, 14, 18, 6, 8, 14, 18, 24, 28, 30, 24, 28, and 30. And your f of i's are 2, 4, 7, 12, 2, 4, 7, 12, 8, 4, 3, 8, 4, 3. Now, what you want to do is basically find the mean of this data. So the first thing that I'm going to do, so you know that if you want to find the mean of some observations, you could do it with x bar is equal to, for example, sigma f of I times x of I as I goes from 1 to n over sigma f of I as I goes from 1 to n. That way you can do it. But now the problem here is that you have to multiply 12 times 18, 4 times 28, 30 times 3. The numbers are a little bit too large. Let me see what sort of gradient 2 now. Number 4. 18. Okay. Now, basically what the answer that we have in the book is not correct, but well, we can go with that as well. Anyway, that doesn't really matter. What matters is that, well, you can use this formula in order to find your mean, and I think that's okay. There is no problem with that. So if I calculate f of I times x of I, I will have 2 times 6 is equal to 12, 8 times 5 is equal to 32, 7 times 14 is equal to 70, and 28, 98. I'll have 18 times 12, which is basically 10 times 18 is equal to 180, and 2 times 18 is equal to 36, so that's 6, 11, and 216, for example. 260. 8 times 24 is 160, and 32, so we have 192. 4 times 28 is 80, and that's 32. 80 and 32, that's 112, right? That's 112. And 3 times 9 is 3 times 30 is equal to 90. Next, what you want to do is basically find sigma f of I times x of I as I goes from 1 to n, which is equal to the sum of all of these numbers. So that's 44, that's 98, 216, 98, 216, 192, 112, and 90. The 12 plus 8 is equal to 20, 22, 2, and then you have a 6 plus 9 is equal to 15, 15, 16, 16 plus 10 is equal to 26, 26 plus 9 is equal to 35. The 3 over here. Actually, the 3 has to be over here, but well, 3 plus 2 is equal to 5, 5 plus 2 is equal to 7, 752. That is sigma f of I x of I, so that's 752. And moreover, basically sigma f of I as I goes from 1 to n is equal to 2 plus 6 is equal to 2 plus 4 is equal to 6, 13, 25, and here you have 12, 15, so that's a 40. That is a 40. Now if you divide these two, what you will get is, so your x bar is going to be equal to 752 divided by 40, which is 752 by 40 gives you, divide by 220, divide by 2, 350, and that is 25, 26. So that's 6, 7, 376. 376. Again, divide by 2, you'll get a 10, you will get 150 plus 35, 38, 188. 188. Divide by 2, you'll get 94. Divide by 2, you'll get 5. Now 94 divided by 5 is equal to what? 1 times 5 is equal to 5, 44. 9 times 1 is equal to 45, 8 times 1 is equal to 40, 4 remain there, 0, 4, and 8 times 5 is equal to 40. 40 is 0. That's 18 times 8. 18 times 8. Okay. Now what you can do in order to make calculation easier, over here for example number 4, they have taken the mean of the data as basically they have rounded this to 19. They have rounded this number to 19, meaning that you can say that you can take this as it's exact 18.8. So rounded up to 19. So that means that my x bar is 19, right? Now my variance, or sigma squared, is equal to 1 over n times sigma of f of I times x of I minus x bar all squared as I goes from 1 to n. So I need to calculate x of I minus x bar. X of I minus x bar all squared. Now x of I minus x bar is, for example, 6 minus 19, which is equal to negative 13. Negative 13 squared is equal to 169. 8 times 19 is equal to 11. I'm sorry, 8 minus 19 is equal to 11. 11 squared is actually negative 11. Negative 11 squared is equal to 121. 14 minus 19 is equal to negative 5, so that's positive 25. 18 minus 19, negative 1, positive 1. 24 minus 19 is 5, so that's 25. 28 minus 19 is equal to 981. And 30 minus 19 is equal to 1121. 30 minus 19 is equal to 11, of course. 11 squared is 121. Now if I calculate f of I times x of I minus x bar whole squared, that gives me, for example, 2 times 169 is, well, 200, and then 120, and then 18, you get 8, 3, 3 and 3, 338. 338. That's 2 times that. 4 times 121 is 480, and 4, that's 484. 7 times 25 is 140, 35, 175. 175. 12 times 1 is equal to 12. 8 times 25 is equal to 160. That's a 200. 4 times 81 is equal to 320 and 324. And 3 times 121 is 363. Now if I calculate here sigma f of I times x of I minus x bar whole squared, if I calculate sigma f of I times x of I minus x bar whole squared as I goes from 1 to n, take n as, for example, the number of your observations in all of these expressions, is equal to basically all of these numbers added together, which is, well, 338, 484, 175, 12, and that's 212, 324, and 363, and that's a 12. 12 plus 5 is equal to 17, 19, 19 plus 7 is equal to 26. 19 plus 7 is equal to 26. 5 plus 8 is equal to 13, 20, 21, 23, and 29. 2. 5, 9, 10, 12, 15, 18. 1896. 1896. So now if basically now your sigma squared, or the variance, is the same thing as basically sigma alpha by this whole thing, which is basically 1896 divided by n, which is sigma alpha y, which is equal to 40, which we can calculate as 1896 divided by 40 divided by 220 divided by 2, we get a 500, 400, 45, 48, 948, 48, 948, again divide by 210, divide by 2, 450, 24, so that's 474, again divide by 2, 5, divide by 2, 274 is 35, 37, 237. Now 237 divided by 5 is 4 times 5 is equal to 20, is the 3 remainder, 37, 5 times 6, 5 times 7 is 35, 2 remainder, 0, 5 times 4 times 5 is equal to 20, so that's 47.4. 47.4 is your variance. Is your variance. That is that. That was number 4. The answer is absolutely correct. Okay. Now let's do question number 5 as well. And let's see what happens. Let's do question number 5 here as well. Okay, so the next question that we have is question number 5. It says, basically you have this table over here, or actually you don't have a different table, but I am creating this table for your x of i's and f of i's. Say that this is x of i, this is f of i. And you have 92, you have 93, you have 97, 98, 97, 98, and you have 100, 200, 409, 100, 200, 409, and the frequencies are 32, 32, 633, 32, 32, 633, or 33 basically. Now, you want to calculate the mean of this data. And you can see that the numbers are fairly large. So, what I'm going to do is that I'm going to take this as the mean of the assumed mean of the data. And I'm going to write the formula for the mean, which is x bar is equal to a plus sigma f of I times d of I divided by sigma f of I, and you can assume that in all of these sigmas that I write, unless stated otherwise, what I mean is I goes from 1 to n. If I mean something else, then I will write it explicitly. Otherwise, what I mean is basically this. So then sigma alpha by d of I times sigma alpha by. Now d of I over here is basically x of I minus a. X of I minus a. So x of I minus a is, for example, 92 minus 98, which is negative 6. 93 minus 98 is equal to negative 5. 97 minus 9 is negative 1, 0. 102 minus 98 is equal to 4. 104 minus 9 is equal to 6. And 109 minus 98 is equal to 10. And now the numbers are fine. There is no need to do anything else really. Now your sigma f of I d of I is, I'm sorry, your sigma, but that was actually correct. I didn't have to erase it. Now I need to calculate f of I times d of I. F of I times d of I. So 3 times negative 6 is negative 18, negative 10, negative 3 is 0, 24, 18, and 30. Now sigma f of I d of I is basically all of these numbers added together. So that's negative 28. That's actually it, but let's take it as 28 plus 3 is equal to 31, so that you have a negative 31 here, and then you have a positive 30 over here, which take it as negative 1, and then over here you have 24 and 18 put together is 2 and 42. Subtract the 1 from it is 41. That is 41. That's sigma f of I d of I. And sigma f of I and sigma f of I is equal to 5, 8, 10, 10, and this is a 12, so that's 22. So then your x bar is equal to A, which is 98, plus sigma f of I d of I, which is 41. 41 divided by sigma f of I, which is equal to 22. So 41 by 22 is 2 point something. So 41 divided by 22. So 1 times 22 is equal to 22. And then you have 30, 18, 19, remainder 0.00 point. Now let's take this as 20. 7, 8, 9, 180. 9 times is equal to 18. No. 8 times 16, 1, 16, 1776, so 176, 180, so that's a 14, and then another 0 here, another 0, so 6 times 120, 6 times 12, 132, so it goes 6 times 6 times that's 6 times is equal to 12 once, 12, 13, 132, 140, 8 remainder. You can still keep going, but I take this as 1.9. So I take this as 1.9. Take this as 1.9. So that's 98 plus 1.9, which is the same thing as 99.9. 99.9. Take it as 100. Round it up to 100. So let's see if the mean is the same over here. That's 100, right? So that means that your x bar is equal to 100. Your x bar is equal to 100. Now what we need to do is calculate the variance. So the variance sigma squared is equal to 1 over n sigma f of I times x of I minus x bar whole squared, as I goes from 1 to n, of course. So now if x of I minus x bar whole squared is equal to so 92, for example, minus 100 is negative 8. That's 64 squared. When squared becomes 64. 93 minus, that's negative 7. That's positive 49. 97 positive negative 3, so that's a 9. What happened here? 7, okay. 98, 2, so you get a 4. 102, 2, you get a 4. 104, 4, you get 16, and 9, 81. And then if you calculate f of I times that, f of I times x of I minus x bar whole squared is equal to, for example, 3 times 64 is equal to 180, and that's a 12, so that's 12, and so that's 192. 2 times 49 is the same thing as that's 100, but minus 2, that's 98. 2 times and 3 times 9 is equal to 27. 2 times 4 is equal to 8. 6 times 4 is equal to 24. 3 times 16 is equal to 30. 18, 48. And 3 times 81 is equal to 240, 243. Well, and if you add all of these numbers together to calculate sigma f of I times x of I minus x bar all squared, you would get 192, 98, 27, 8. What is that? 27 plus 8 is equal to 15, 35. 35 plus 98 is equal to 1333. And then you have 24, 48 is 60, that's 2, so 672, that's 72, and then 243. We get 5 plus 5 is equal to 10, 1, 10, and this is 24, 2, 4, 6, 640. 640. So, you have sigma f of I x sub, this whole expression 640 divided by n, which is 22. That is 640 divided by 22, which is 640 by 22 divided by 211 divided by 2, 320. Now 320 divided by 11 is the same thing as 2 times 11 is equal to 22. That's a 10. And 8 times, 9 times is 99. One remainder. 0.0. 0. Again, 9 times, that's 99. Again, you would get a 1 remainder, so again you would get 09, 09, repeating. So you get 29.09 repeating. So I take it as 29.1. 29.1 is your variance. Is your variance. Let me check the answer here. Number 5, 29.09. Number 6 is find the mean and standard deviation using the shortcut method. Okay, so I'm going to end this video here, and then in the next video we will do basically all the exercises starting with 6 and see where we can get. I'll see you in the next